Hi guys, today we're going to learn about goal 3, writing partial fraction decompositions of rational expressions with linear factors. So remember, rational expressions, this means that it's a fraction. And basically what we're going to do is we're going to break it down into two other or more fractions to make it more simple, and our new fractions are going to have linear denominators. So if you want to follow along in our book, it's chapter 6, section 4, and we're in unit 3A. Okay, so here's a quick example of what a partial fraction decomposition is going to look like. So we will be starting with this left side, and we are going to have to break this down. Notice that this denominator is a quadratic. It has an x squared. And what we want to do is break it down so that it looks like this right side. Notice that on the right side, both of the denominators are linear. They only have x to the first power. So you guys know that if we started with this right side and we wanted to combine these fractions, you know that you would have to get a common denominator. Our common denominator for this would be x minus 5 times x plus 4. And to get that common denominator, we would multiply. And whatever we multiply each fraction by in the denominator, remember we also have to multiply by that factor in the numerator. So on our first fraction, let me get rid of this. In our first fraction, we would have had to multiply by x plus 4. In the second fraction, we would have had to multiply by x minus 5. Once you distribute the 2, distribute the negative 1, and combine your fractions together, you would end up with x plus 13 over x squared minus x minus 20. However, this is what we've already learned. This time, I'm going to give you this final answer, and you have to tell me what fractions does that break down into. So let's try one. Well, first, let me tell you why this is important. This is super important if you are going to take calc in the future, because when you take calc, a lot of problems will ask you, find the area under this curve. And for example, it might say find the area from 6 to 10. And you have to figure out this area right here. If your function that you're finding the area under is a rational function like this, the first step to do this problem is to do partial fraction decomposition. When you get to college and you're in a calc class, they'll expect you to have an idea of partial fraction decomposition already. So let's get started. Here's our first example. This is the one I actually showed you before. So I'm going to show you how we can figure out what two fractions make up when they're added together would give you this final answer. So it says find the partial fraction decomposition of this fraction. Here's our function. Now the first step is we need to take our denominator and factor it out. For this, I'm going to go off to the side. So let's see. I have x squared minus x minus 20. To factor this, I need to think, since a is 1, there's no greatest common factor, first off. So now I need to think of two numbers that can multiply to give me negative 20 and add up to negative 1. Let's think about it. Those two numbers would be negative 5 and positive 4. So we'll take those as our factors, x minus 5, x plus 4. You could always double check to make sure that this is correct by foiling it back out. First, x times x is x squared. Outside, x times 4 is 4x. Inside, negative 5 times x is negative 5x. and last, negative 5 times 4 is negative 20. These middle two terms right here combine, let's put some equal signs in here, to give you negative 1x. So since this matches what we started with, we know it's correct. Okay, so I know that this is my factors. These are my factors for my denominator. So what I'm going to do is I'm going to take those factors and I'm going to write them as the denominators of my linear fractions. These linear expressions have to be the denominators of my fractions for the partial fraction decomposition. Now the numerator, it's not just 1x and 13, because remember, it doesn't work like that. You would have to get a common denominator and then multiply your numerators by the missing factor, etc. So what we're going to do is we're just going to call them A and B because we don't know what they are. Now we're going to solve this as we would solve a rational equation. When we're solving a rational equation, the first step is to get rid of the denominator. I know that this denominator actually factors out because I just did it. It's x minus 5 times x plus 4. So I'm going to rewrite that first. Remember, the first step in solving a rational equation is to make sure all of your denominators are factored. So now I want to get rid of the denominators, so I need to go through and multiply every single term by any factor that I see in the denominator. So I know I see x minus 5, so I'm going to multiply by that in every single term. I also see x plus 4, so I'm going to multiply by that in every term. As long as I'm multiplying every single term by the same thing, you're allowed to do that. Okay, so now let's go through and cancel out factors that are found in the numerator and the denominator. X minus 5 is in both the numerator and denominator for this term. So is x plus 4, so those cancel out. In this first term on the right side, x minus 5 is my common factor that can reduce out. On the second term, x plus 4 is the common factor. Now let's rewrite what's left. So we have x plus 13 equals a times x plus 4 plus b times x minus 5. The next step is to distribute a and b. So we're going to take a and distribute, take b and distribute. So we get x plus 13 equals ax plus, now you can either write this as 4a or a4. I prefer 4a plus, now we're going to distribute b, so we get bx minus 5b. Okay, now we need to group up our terms. So we want to group up the terms that have x in it and the constant terms. Okay, so first I'm going to put the x terms. So I have ax plus bx. I want to put those first because they have x in them. Next, I'm going to put my terms without an x in it, just the constant terms. So those would be positive 4a and negative 5b. Okay, the reason for grouping this is so that we can take in our first group and factor out an x. So that's what I'm going to do. So I'm going to leave the left side the same, take x out of the first group. So I'm left with a plus b. In my second group, there's no common factor, so I'll just leave it 4a minus 5b. Okay, notice on the left side we have an x term and a constant term. On the right side we have our x piece and our constants. So in order for the left side to be equal to the right side, here's what we know. We know that a plus b has to be equal to the coefficient of x. And 4a minus 5b has to be equal to the constant 13. So we're going to set these as two separate equations. So we have 1 equals a plus b, and we have 13 equals 4a minus 5b. We have two equations with two unknowns. We should be able to solve this as a system of equations. In this chapter, we learned that solving a system of equations is easy to do using matrices. So what I'm going to do is I'm going to set up a matrix to solve this equation. So I see that I already have my a term first, then my b term in both equations. So I can just go ahead and make my coefficient matrix. So I have 1, 1 for my first equation. Now for my second equation, I have the coefficients 4 and negative 5. That's multiplied by my variable matrix, which is a and b. And that's equal to my constants, which is 1. And for my second equation, my constant is 13. Now what we're going to do is we're going to take this and plug it in to matrix A in your calculator. And we're going to take our constants and plug it in for matrix B in your calculator. Let me pull that up. Okay, let's see. Take your calculator out. All right, so we need to plug in two separate matrices. Okay, so remember, go to second matrix, go over to edit. Matrix A, we need it to be a 2 by 2. Let's see. Our values that we want are 1, 1, 4, negative 5. So let's go back and type those in. We have 1, 1, 4, negative 5. Now go back to matrix again and edit matrix B. We want this to be a 2 by 1. And our values are 1 and 13. So make sure you have matrix A and matrix B plugged into your calculator. Now go back. So in order to solve this equation, we want to get our variables by themselves. So we want our A and B matrix to be alone. In order to do that, what we need to do is multiply by the inverse of A on both sides. So we need to take this. Remember, in matrices, left side multiplication is different from right side multiplication. So we need to take this, move it over a little bit, and we need to multiply by the inverse of A on the left side. So go back to your calculator, type in inverse A times B on the home screen. Hit enter, and we'll see our answer pop up as 2 and negative 1. So what that means is that A is equal to 2 and b is equal to -1. Okay, so that's not really our final answer. We want to go back up to our partial fraction decomposition up here where we had x plus 13 over our denominator. Well, let's go back even one step further. Over x squared minus x minus 20 equals a over x minus 5 plus b over x plus 4. Now what we're going to do is we're going to take this and we are going to plug in our values for a and b. So let's write it down. We have x plus 13 over x squared minus x minus 20 equals, our a value is 2, we found, over x minus 5 plus our b value, which is -1, over x plus 4. Now you could write this as a minus sign here and just make it 1 over x plus 4. That's equivalent, but it's not necessary. So this is your final answer for this problem. This shows that when you're starting with this fraction, it's a rational function with a quadratic denominator, we can break it down to be equal to these simpler fractions with linear denominators. And these are equal on both sides, the left and the right. So that problem's finished. Okay, I have 2 problems for you guys to try on your own. Here's the first one. 2x plus 5 over the quantity x squared minus x minus 2. Go ahead and try this. Pause the video and try it by yourself. When you're finished, resume the video. I'm going to show you how to do it so you can check your work. All right, so remember the first step in solving these problems is factor out your denominator. So this one has no GCF. Our a value is 1, so it should factor as 2 binomials. We need to think of 2 numbers that multiply to give us -2 and add up to -1. That would be -2, +1. Okay, now we're going to break it down. So we're going to put a over our first factor plus b over our second factor. Next, we're going to solve this as a rational equation. So the first step is to get rid of the denominators by multiplying by any factor we see. So we need to multiply every term by x minus 2. And we need to multiply every term by x plus 1. All right, cancel out common factors and rewrite what's left over. So on the left side, we have 2x plus 5. On the right side, we have a times x plus 1 plus b times x minus 2. Distribute a and b. You have 2x plus 5 equals ax plus 1a plus bx minus 2b. Next, you look for any any terms that have x in it and any terms that don't have x in it that are constants. Now we regroup. So we write the terms that have x in them together, and we write the terms that are constants together. Okay, the next step is to factor x out of these terms that have x's in them. So we'll get x times the quantity a plus b and this other part doesn't factor. So remember, on the left side we have an x linear term, and then we also have this 5 constant term. And we know that in order for the left and the right side to be equal, the a plus b has to be equal to 2, and the 1a minus 2b has to be equal to the constant positive 5. So we're going to set it up as a system of equations. We have 2 equals a plus b, and we have 5 equals 1a minus 2b. It's already in order, the constants on the other side of the equal sign. We have our a term first, then our b term, so we can go ahead and make this into a matrix equation. So we have our constant matrix goes first. For our first equation, our coefficient matrix goes first. Our coefficients are 1 and 1. Then for our second equation, our coefficients are 1 and -2. Next, we write our variables, a and b, and this must be equal to the constants. For our first equation, the constant is 2. The second equation, the constant is 5. Now plug this into your calculator. We have matrix A times our variables equals, and we're going to plug this into matrix B. Okay, go to your calculator, edit. It's a 2 by 2. We have 1, 1, 1, -2. Then go back to edit again. This time we want to edit matrix B. It's still a 2 by 1. But this time our constants, let's double check, are 2 and 5. All right, so we have matrix A and matrix B. Go back to your home screen. We're going to type it just like we did the last time. We have A inverse times B. I'm just going to actually go up and select that and hit enter again. Now, this is telling us the answer is the matrix 3, -1. What that means is that the variable A is 3, the variable B is -1. So let's go back to our problem. Remember, we had to multiply by matrix A inverse on both sides. It cancels over here. So we got A, B equals 3, -1. So remember, that means A is equal to 3, B is equal to -1. Now we just need to go back and fill that in. So we have 2x plus 5 over x squared minus x minus 2 equals, our a value is 3. Our first denominator was x minus 2. Our b value is -1. Our second denominator is x plus 1. So this is your final answer. You can check it by adding these together by getting a common denominator and making sure that it's equal to the left side. All right, next, I want you to try this one. Example 1 practice, you have x plus 11 over 2x squared minus 5x minus 3. For this one, it's going to be the same idea. You're going to break it down. So the first step is to factor your denominator. This time we have an a value of 2, so we're going to have to use AC method. There's no greatest common factor here. So I'm going to take this actually off to the side and factor it. Let me get some more space here. All right. So the first thing we need to do is factor our denominator. So we have 2x squared minus 5x minus 3. I'm just going to jot that down so I can factor it. I know my a value is 2, my b value is -5, my c value is -3. For AC method, I need to multiply a times c first. Jot that down off to the side. A times c is equal to -6, and my b value is -5. So I need to come up with two numbers that multiply to give me -6 and add up to -5. That would be -3. No. Let's see. -6 and +1. So we're going to use those two numbers. To break down my middle term. So I have 2x squared. Now I'm going to break down my middle term to be -6x, +1x, and then -3. So basically all I did was took the -5x and split it into -6x and +1x. Those are equal. -5x is equal to -6x plus 1x. So that's allowed. Next, I group and make sure that there's a plus sign between your groups. If there's not, you need to include the negative in the group and make a plus sign between. All right, factor the greatest common factor out of each group. So the first group, the greatest common factor is 2x. I'm left with x minus 3. My second group, the greatest common factor is just a 1. So I'll just go ahead and pull out a 1. And I'm left with x minus 3. Now that's good because what I was left with is the same. That's the goal here when we're factoring with AC method. So we can take that out. It's kind of like a greatest common factor of each group. When I take out the x minus 3, in my first group, I'm left with 2x. In my second group, I'm left with +1. So this is my factoring for the original 2x squared minus 5x minus 3. So now that I know my factors, now I can write this out. So I have x plus 11 over 2x squared minus 5x minus 3 equals x minus 3 plus blank over 2x plus 1. I'll label my numerators as a and b. Now that we're here, go ahead and pause if you haven't already and see if you can work the rest of this problem out. All right, hopefully you worked it out. Remember the first step is to multiply by the denominators to get rid of the denominators. So first I'm actually going to rewrite this as the factored form, x minus 3 times 2x plus 1 Okay, now I need to multiply by every factor that I see. So I have x minus 3 gets multiplied by every term, and 2x plus 1 needs to multiply by every term. All right, cancel out your common factors and write what's left. So we have x plus 11 equals a times 2x plus 1 plus b times x minus 3. Distribute, you get 2ax plus 1a plus bx minus 3b. Rewrite it, group up your x terms, group up your constant terms. So we have 2ax plus bx plus 1a minus 3b Okay, remember, our x terms, you have to factor out the greatest common factor, which is the x. So we are left with 2a plus b. Our constants, you can just leave those alone for now. Now, in order for this left side of the equation to be equal to the right side of the equation, we know the constants have to equal the constants, and the linear term coefficient has to equal this linear term coefficient. Remember, it's an imaginary 1 right there. So let's set it up. We have 2a plus b equals 1, and our other equation is 1a minus 3b equals 11. Turn this into a matrix equation. We have 2, 1, 1, negative 3 times our variables a, b equals our constant matrix 1, 11. Plug this into your calculator for matrix A as your coefficients. Matrix B can be your constants. Okay. Now we also have to edit matrix B. It's still a 2 by 1. Let me double check my constants here. We have 1 and 11. Okay, remember to solve this matrix equation to get the variables by themselves, we need to multiply by the inverse of A on both sides. It cancels out on the left side, leaving the variables alone. And this is what we need to type into our calculator. A inverse times B. That'll give us our answer for our variables. So go back to your home screen on your calculator. You can just go up, hit enter, hit enter. Our answer is 2, negative 3. So let's come back to our problem. We have AB equals 2, negative 3. What that means is that the value of A is 2, the value of B is negative 3. Now all we need to do is fill those in to our partial fraction decomposition. So you're literally just going back to the beginning of this. You can literally just copy and paste it. Oh, this is not working. Oh my gosh. Okay, I'm just going to rewrite it. X plus 11 over 2x squared minus 5x minus 3 equals, the A value is 2 over x minus 3 plus our B value is negative 3 over 2x plus 1. Again, you could write this as minus and a positive 3 in your numerator if you want, but it's unnecessary. You don't really have to do it. You just can if you want to. Here's our final answer for this partial fraction decomposition. Okay, that was example 1. Example 2 has to do with improper fractions. This is basically the same thing. However, notice that this is not a proper fraction. The degree of the numerator is equal to the degree of the denominator. If this ever happens, the first step that you need to complete is divide this out to simplify it first. So, in order to divide 2x squared plus 5x minus 4 by x squared minus x, sadly for this we can't use the method where we put the linear term in the box. I can't think of the name of the method off the top of my head, but it doesn't work because that only works when you have a linear term like x minus 5 or something like that. when you're dividing by that, if that's your divisor. This is not a linear divisor, so we have to use long division. So our first step, we're going to set up this long division. Let's think back to Algebra 2, or we reviewed it also earlier in pre-calc this year. Remember, you need to make sure that all powers are represented. In this case, they are. We have our quadratic, our linear, and our constant. If all powers are not represented, you need to put in a 0. All right, start with our first term, 2x squared divided by the divisor. 2x squared divided by x squared gives us a 2. Multiply 2 times x squared is 2x squared. This should always match up. If it doesn't match up, you did something wrong. Don't forget to distribute the 2 to the negative x also. You have to multiply the 2 by the entire divisor. Okay? So 2 times negative x, that gives us negative 2x. Remember, our steps are divide, multiply, subtract, bring down. So we divided, we multiplied. Next step is subtract. You need to make sure you subtract the entire thing. So when we do 2x squared minus 2x squared, that gives us 0. That cancels out. However, this is where some people mess up. We have 5x minus negative 2x. That gives us 7x. Next, bring down your negative 4 and continue to the next step. 7x divided by x squared. 7x does not divide by x squared, so this is our remainder. So we have 7x minus 4 over the divisor, x squared minus x. So what we just found out is that our original problem, 2x squared plus 5x minus 4 over x squared minus x, is actually equal to 2 plus 7x minus 4 over x squared minus x. Now, the only difference between example 1 and what we're doing now was that first step. From here, all you need to do is do the exact same steps that we did in example 1 on this leftover rational expression. So you can either write the 2 plus the whole time, or what I like to do is just come back to that. Just don't forget to come back to it. So we have 7x minus 4 over x squared minus x, and we're literally doing exactly what we did in example 1. So the first step, remember, is to factor your denominator. This denominator actually has the greatest common factor. It's x. So this factors as x times x minus 1. So we know that our denominators are x and x minus 1. Our numerators are still a and b. Okay, we're solving this as a rational equation. So multiply by every factor that you see in the denominator. Cancel out like factors in your numerator and your denominators, and rewrite what's left over. So we have 7x minus 4 equals a times the quantity x minus 1 plus b times the x. Distribute a and b again. It's literally the same thing we've been doing. So we get ax minus 1a plus bx. Group up your x terms. Group up your constants. Rewrite it in that order. So we have ax plus bx minus 1a. Okay, in our x terms, we have to factor out the GCF, which is our x. So we have x times a plus b. You can leave your constants alone for now. Remember, for this left side to be equal to the right side, the constants have to be equal. So I know that negative 1a must equal negative 4. And my coefficient of my x's have to be equal. So I know a plus b must equal 7. Now before you go and plug this into your calculator, pay close attention. We have an equation that's only one variable. We can solve this from here without plugging it into our calculator and making a matrix equation. Negative 1a equals negative 4 means that a must be equal to positive 4. I got that by dividing by negative 1 on both sides. If a is equal to 4, I can substitute that in. Therefore, b is equal to 3. Once I know my values for a and b, I can go back up to the beginning and I can fill in my a and b, but don't forget that that was only this rational expression. You still have the 2 plus in front of that, and this was our actual original question, so we need to write that down. So we have 2x squared plus 5x minus 4 over x squared minus x. And here's our partial fraction decomposition. So it's equal to 2 plus the a value, which was 4, over x, plus the b value, which is 3, over x minus 1. Here's the final answer. Remember, you can always check your work by, on the right side, getting a common denominator, adding your fractions together, and making sure it's equal to the left side. Okay, I have some practice problems for you. 2 of them. If class is about to end, make sure you finish these tonight, okay? I'll go through them still, though. All right, here's the first one. Since it's an improper fraction, the first step is to divide. So divide it out. You have 3x squared plus 12x plus 4 divided by x squared plus 2x. So divide, multiply, subtract, bring down. This doesn't divide by x squared plus 2x, so it's your remainder. So we have 3x squared plus 12x plus 4 over x squared plus 2x equals 3 plus 6x plus 4 over x squared plus 2x. Now remember, you can just take this rational part of this equation of the right side and just work with that for now. Why isn't it giving me more space? All right, so let's see here. We have 6x plus 4 over x squared plus 2x. My factors for my denominator are x and x plus 2. I'll label my numerators a and b. Go ahead and rewrite your first fraction so it's in the factored form in the denominator. Multiply by every factor you see in the denominator to get rid of the denominators. Cancel. Rewrite. Distribute. Group your x terms. Group your constants. Eventually you might get good enough at these that you can skip some steps, by the way. Okay, factor out your GCF out of your x terms. So that's an x. You're left with a plus b. Okay, remember the coefficient of x has to be equal to the coefficient. The constants have to equal the constants. So we have a plus b equals 6 and 2a equals 4. One of these is solvable without using a matrix. Even though it's a system of equations, this equation only has one variable. So go ahead and solve it. You get a is 2. Therefore, b must be equal to 4. Finally, go back to your original question and fill in your a and b. But don't forget, you have to go back to the original and have the 3 plus in the front. So 3x squared plus 12x plus 4 over x squared plus 2x is equal to 3 plus our a value, which is 2, over x plus our b value over x plus 2. There's your final answer for that one. Okay, last one. This is definitely an improper fraction. The numerator has a higher power than the denominator. So divide it out. Make sure all powers are represented. In this case, they are, so we're good. Okay, x to the 4th divided by x squared leaves us with x squared. Multiply. Subtract. Bring down. Divide. X cubed divided by x squared leaves me with an x. Multiply. Subtract. Bring down. Divide again. 5x squared divided by x squared gives me 5. Multiply 5 times x squared. 5x squared. 5 times negative 4x is negative 20x. Subtract. Okay, that cancels. That's good. Negative 9x plus 20x, because it's a minus a negative. So let's see, that gives us positive 11x. Bring down our plus 4. Finally, we're finished because 11x does not divide by x squared, so that leaves us as this as our remainder. So that means 11x plus 4 over x squared minus 4x. So let's rewrite this. We have x to the 4th minus 3x cubed plus x squared minus 9x plus 4 over x squared minus 4x is equal to x squared plus x plus 5 plus 11x plus 4 over x squared minus 4x. Okay, let's move this over because we're running out of room here. I don't know why it always does this. Oh, Last try. Come on. There we go. All right, let's give some space over here. All right, there we go. That was a struggle, but we're ready. Okay, so we need to break down this fraction so that it has a linear factors in the denominator. So this is literally the same thing we've been doing the entire class. First step is to factor your denominator. So our factors are x times x minus 4, because x is your GCF, it's the greatest common factor. Remember, we write our numerators as a and b. Multiply by every factor you see in the denominator. To get rid of the denominators, make sure you multiply in every single term though. You can only multiply by something if you do it in every single term in an equation. You can't do that with just an expression. Just when it's an equation, you can do this. All right, cancel common factors from the numerator and the denominator. Rewrite what's left. So we have 11x plus 4 equals a times x minus 4 plus b times x. Distribute. Group. Factor your x out of your ax and bx. That leaves you with a plus b. Okay, remember we need the constants to be the same, the coefficients to be the same. So set it up as an equation. We know 4 equals negative 4a and 11 equals a plus b. You could set this up as a matrix, but this equation only has one variable, so go ahead and solve it. A is equal to negative 1. Therefore, let's plug that in. B is equal to 12. Once you have your A and B values, you're nearly finished, but you're not totally completed. You have to go back to the original question and rewrite it. So you have x to the 4th minus 3x cubed. We're going to just rewrite this whole thing. Okay, equals x squared plus x plus 5 plus our a value, which is negative 1 over x, plus our b value, which is 12 over x minus 4. Remember, you could write this as minus and a positive 1 over x, but you don't really have to. Here's your final answer. You can check it by getting a common denominator for all these on the right, adding them up, making sure it's equal to the left side. There you have it. You guys know how to do partial fraction decompositions. We'll do more practice in class tomorrow.